Okay, it's Pythagoras part 2. We're just going to look at Pythagoras in 3 dimensions, and then we're going to do a really tricky problem-solving question as well. Okay, so last time we looked at a problem-solving question which is quite standard, and we looked at converse Pythagoras. Okay, so let's just go for Pythagoras in 3D. So Chris wants to store his umbrella in a locker. It shows you the locker. It says he's got an umbrella that's 85 centimeters long, and he thinks it will fit from P to N. Okay? So the first thing I'll be doing is saying, okay, well, all these dimensions are already on the drawing, so I really don't need any of this information. Let's just cancel all that out. The only thing that's really relevant here is that it's 85 long, and it's going from P to N. So I would just draw a little line from P to M, just to show me what's going on. If you've got a ruler, that would be good. So 3-dimension with this umbrella is going to go in. And if I want to work out the length of that, because I'm going to work out the length and compare it to the length of the umbrella, I will need to use Pythagoras. Okay, so that shape, that line, has got a height of 70, which is shown here. And the base of it, I actually don't know the length yet, because this isn't on the drawing. So I need to work out this length, and then I can work out this length with Pythagoras. Okay. To get this length, I'm going to think about the shape in plan. So that's the walker, looking from the sky. Okay, there's that line. Oops. There's that line there. What are these dimensions? 40 by 40. Simple. There's my right angle. So I'm trying to find the longest side. So I'm going to be doing Pythagoras add. So I'll say that 40 squared plus 40 squared is going to be equal to x squared. So that's 3,200 is going to be equal to x squared. So the square root of 3,200 is going to be equal to x. So let's do that in the calculator. Square root of 3,200 is 56.57. So x is equal to 0.57. And to get to that number, that was 40 squared, which is 1,600 plus 1,600. Okay. So now I know this length here. I need to do Pythagoras one more time. To get this bigger length, I'm now going to do 70 squared plus 56.57 squared. And that's going to be equal to this length here. Okay. That's going to give me 8,100.16 is equal to x squared. So then I'll say the square root of 8,100.16 is equal to x. So the square root 8100.16 is 90. So x is equal to 90. Centimetre is just to use units this time because that's the last of the lines working. So we know this is 90, and the question's saying, will his umbrella fit in? So we'd write a small explanation. We would say, yes, it will fit. And why will it fit? Because 90 is greater than 85 centimetres. Okay, so the space is bigger than the umbrella, therefore it will fit. Okay, apologies for the writing, I'm still getting used to this pen and pad. But that's Pythagoras in 3D. You're going to be using Pythagoras once to work out one of the lengths, and then using it again to work out your final length. Okay, nice and straightforward. Now this question is brilliant, really quite a challenging question, but if you just concentrate and do the steps logically, it'll be okay. So once we see a circle with some kind of shape cut out, we should be thinking Pythagoras. So let's read. The depth of water at its deepest point is 5. So let's score that out and draw in the diagram. Okay, there's 5. So this dimension in here is 5. I'll zoom it around a bit. So that's 5. The width of the water surface is 18. That's already shown. The radius of the pipe is r. Okay, so we could draw an r. There's an r. There's an r. And that's an r as well. Okay. The distance from the centre O of the pipe to the water surface is x. So from here to here is x. And we know the water is 5 deep. So the first thing is write down an expression for x in terms of r. Okay, so there's 2 things you could be thinking on here. the classic is to draw out our triangle, our right angle triangle. Okay. So we'd be thinking, all right, I know that's x, so let's draw a right angle triangle out. I really should use a ruler, apologies. We know this is x. We know this whole thing is 18, so half of it's going to be 9. And we know this is r. Okay, so we do know that r squared is therefore going to be equal to 9 squared plus x squared. Okay, that's not exactly what the question is initially asking, as that's probably more to do with the second part. Write down an expression for x in terms of r. This line here is r. This whole line is r. From there to the base is r. Okay, so r is equal to x plus 5. Okay, that's probably the trickiest bit, I think. Yeah. Or x, you could say x, I suppose, is equal to r. Take away 5. Yeah. If that's x, that's the full r. R, take away 5, leaves with x. Okay, so you can use either one of those expressions. Okay. That's the tricky bit in this question. Okay. Trying to link the two unknowns, because usually they'd be looking for r, this length in here. So that's a bit mean, I think, to do that. We can't solve this because there's two unknowns. We can only solve it with one unknown. So we need to substitute in one of these expressions into this equation. Okay. And that's how we're going to complete section B. So I think the easiest one to put in is the r. Okay, so I'm going to put this expression into here. Okay. So I'm going to say that x plus 5 squared is equal to 9 squared plus x squared. So all I've done there is I know that r is x plus 5, so I've taken x plus 5 and put it in here. X plus 5 squared is equal to that. And then you just break out the brackets. Okay, so we know that x times 5 and x times 5 is going to give me x squared, 5x, 5x and 25. So that's going to be x squared plus 10x plus 25. And that's equal to, I'll just write 81 plus x squared. Okay. So far, I mean, it is tricky, right? But really, you know you want to use Pythagoras. And the hardest bit, I think, is recognizing, well, wait a minute, I can't solve that because I've got too many unknowns, so I need an expression. Okay? That's the tricky part in that question. Okay. Once we start this, it's quite straightforward. We're just using regular solving the equation. Yeah. So we've got an x squared on both sides. We can cancel them out. Just take an x squared away from both sides. That's allowed. So that'll be 10x plus 25 is equal to 81. And now we're all the numbers on one side and the letters on the other side. So we'll keep 10x here. I'll take 25 away from both sides. So I take 25 away from both sides. That's going to give me 56. And then to get rid of the 10, divide both sides by 10. So that's going to be 5.6. So I know that x is 5.6 centimetres. But the question's not asking that. It's asking for the radius. So I know the radius is 5.6. So the x is 5.6. I need to add 5 to that to work out the radius. So that's going to be 10.6 centimetres. Okay. That is a very mean question. Very, very tricky question. But I think when you see it and you work through it, you think, I could do that again. Because all you're doing is finding your right angle triangle. You're writing down your Pythagoras, there's marks for that. And then we substitute in one of these formulae. Yeah? We remember to break out our brackets properly. And then we just solve as we're solving a normal equation. Okay. So I hope that's helpful. The only thing I never really went over was the distance between 2 points, coordinates. Just to quickly discuss that, all that's really talking about is, say I had, I'll just be very, but you know, that makes me sad. I think I'll do a line. So say I've got my x, my y, so there's my y, sorry. Try and make it straighter. And here's my y. If I was to draw a point, so let's call that 3, 4. Okay. And then down here, I've got -5, -6. A typical question could ask, what is the distance between these 2 points? Okay. Now we can't work out that distance because that's a diagonal distance without using Pythagoras. Okay. So to use Pythagoras, we need to make a right angle triangle. Okay. So if you've got a graph paper, you can draw it. Okay. But if you don't, you can just use the expression which is above. The expression above looks quite horrible, okay? It's saying that d, which is this bit here, is equal to x2 take away x1 squared plus y2 take away y1 squared. Okay. And that's all square rooted. So it looks quite... handwriting is so bad, I apologise. And that's all square rooted. Now, all that really is Pythagoras, okay? That equation is saying that this line here squared plus this line here squared equals this line here squared. And all this is trying to do is work out your distances. Okay. So let's think about it. Let's call this then x1 and y1. And let's call this point here x2 and y2. So what's the distance in the x direction? Well, we could do 3 take away negative 5. Okay, take away negative means add it, so that's going to give me 8. Okay. Now look at the y's. y2 take away y1. So 4 take away negative 6 means 4 plus 6. That gives me 10. Okay. And it makes sense, doesn't it? If this is minus, so let's do the y's first. This is 6 down, and that's 4 up. To go all the way up, I'm going up 6 and then up 4, which is 10. For the y's, this is 5 over to the left, that's 3 to the right. So I need to go 5, I need to go 3. So this equation always holds true, but you could just, in your head, try and visualize this and work out the signs. Okay, so we're saying that d squared is equal to 10 squared plus 8 squared. So therefore d is equal to the square root of 10 squared plus 8 squared. Okay, simple. So this equation here, if you can remember that, is excellent. So just label your coordinates. Either one can be 1 or 2, but the point is x1 and y1 are together, and x2 and y2 are together, and you're taking away, you're not adding, because you want the difference. You want to know the difference between this coordinate and this coordinate. Okay, so that's the only thing I'm not going into huge depth with, but it doesn't come up very often.